Can an AI take a psychology survey and produce data that looks like it came from real people? To find out, I ran the same survey on 177 humans, and then I made ChatGPT take the same survey as each of them. I measured 91 different variables, things like political attitudes, emotions, personality traits, relationship satisfaction, burnout, you name it. Then I took each participant's demographic information and I made API call to ChatGPT. The prompt was basically take the exact same survey as if you're this participant with these demographics. So now for every human, I had an AI demographics only persona answering the same items. But then I asked a second question. What if we give the model more to work with? Demographics are kind of blunt. Two people can have the same age, gender, education, politics, and still be wildly different. So I ran another condition. I gave ChatGPT the participants' demographics plus their big 5 personality traits: extroversion, agreeableness, conscientiousness, neuroticism, and openness. And I asked it to take the survey as that person. Now I've got 3 versions of each person: the real human, the AI with demographics only, and the AI with demographics plus big 5. And the results are very exciting. First, the simple check, the average score on each variable. Here, the big 5 personas are closer to the human averages than the demographics only personas. The effect is small but consistent. If you only cared about matching group means, adding big 5 helps a bit. Next, I looked at the spread of the data, how clustered responses are around the mean. Humans have a lot of variability. People pick extremes sometimes. The demographics only persona didn't. They were too average. The distribution was squished toward the center. And when I added the big 5 traits, the spread became much more human-like. This was actually the biggest win for the big 5 in the whole project. It pulled the AI away from the generic average person and closer to the variability you see in real human samples. Okay, so far so good, but averages and spread are still group level. The bigger question is, can the model match individuals? To answer this, I basically asked, for each participant, how close is the AI persona to that person's actual response across all 91 variables? I used an individual level distance measure. Think of it like, how far apart are these two response profiles? Standardized so variables are comparable. And yes, giving big 5 made the AI closer to the real person. It's not an enormous effect, but reliable. Roughly 60% of participants were better matched under the big 5 condition than under the demographics only. So personality helped not just at the average level, but at the individual level too. But does it track individual differences on each construct? To answer this, we need to switch the lens. Instead of looking person by person across all constructs, I looked construct by construct across all people. For each variable, say anxiety or trust in scientists or doom scrolling, I asked, across participants, does the AI reproduce who is high and who is low the way the human data does? And here the big 5 effect was big. For most constructs, the demographics-only personas were basically not tracking individual differences at all. The correlations were near zero. With big 5, the correlations jumped up noticeably, and about 3/4 of the constructs improved. So this is a major point. Big 5 isn't just changing the overall level of answers. It seems like it's helping the model recover some real person-to-person variation. There's another individual level test that's a bit more subtle. For each person, imagine their pattern across the 91 variables. Maybe they're higher on anxiety, low on aggression, moderate on trust, and so on. That pattern is like a fingerprint. I computed a within-person profile correlation. Does the AI reproduce that person's pattern across constructs? With demographics-only personas, that profile similarity was close to zero after standardizing, meaning it wasn't really capturing the distinctive pattern. For the Big Five persona, it jumped a lot. About 75% of people had a higher profile match under Big Five than under demographics only. So personality info seems to help recover the structure of how traits co-occur within a person. So at this point, it looks like, okay, personality information is helping. But I still wasn't convinced that Big Five was carrying person-specific signal, like this model is actually picking up something about this particular individual and reproducing their pattern. Because there's another possibility, maybe giving the model any personality profile, any numbers at all, just makes it more willing to vary its responses. That would improve spread, and it might even improve some correlations without actually being grounded in the real person. So I ran a control. I scrambled the Big Five information. Literally. I took the personality traits and randomized them so each participant got a Big Five profile, but it was somebody else's profile, basically random. Then I did the same thing. Take the survey as this person with these demographics and these Big Five traits, except the traits were wrong. And here's the crazy part. Random Big Five information did sometimes improve things slightly compared to demographics only. Not always, and in some metrics it actually made things worse, but in a couple of the individual differences measures, it nudged performance up a little. But real Big Five information beat random Big Five information very clearly. When I directly compared the true Big Five to the random Big Five personas, the true traits were better on basically every metric. The biggest gap was again variability. Real Big Five produced much more human-like spread than random Big Five. And on the measures that look at whether the model tracks who is who, like correlations between the human and AI responses across people and across variables, true Big Five was substantively stronger than random. So the takeaway is real traits carry signal that the model can use to better match individuals and better match the structure of human data. So where does that leave us? Can an AI take a psychology survey and produce data that looks like it came from real people? Well, kind of. It can imitate the broad averages, and giving it personality info helps a bit, but it still doesn't fully behave like real human data in the way researchers care about. In my view, we are still far from AI respondents replacing humans. Even with Big Five, it's not human quality data. The gains are real but modest, and the gap is still big. And until further notice, the null hypothesis is you still need humans.